Okay, welcome everyone back to All Things Data. We're going to jump straight into the next talk, and we often talk about people, process, technology, and or tools. And as a Python conference, we have a lot of tools coming up, but today we're going to be talking about people and process, and in particular around data contracts and how they can help us, get more data quality and all that good stuff that we're actually trying to do with data. So I'm really excited for the talk next from Ryan Collingwood. I'll just give a quick introduction to Ryan. He is a boundary spanner between business and IT concerns. He's lived product management, consultancy, iteration management, business analysis, data analysis, software developer, quality assurance to where it started as IT support. Every day he practices a bit of all this to deliver pragmatic and maintainable solutions. He loves the journey both as a contributor and a coordinator, from the wrangling, modeling, sampling, digging for insights and all the important communication of insights and further actions. And he gets a kick out of teaching others to finish the many water bodies of data, whether they be ponds, lakes, or swamps. So let's hear, put your hands together for Ryan Collingwood talking about data contracts, consensus as code.
Thank you. I'm really excited to be here at PyCon in Adelaide. It's just fantastic energy, and thank you for all being here. So who am I and what is my current context? Because I feel like context is really important to share whenever you're dispensing advice. I'm currently working in the team of data and analytics at Oraton. If you're unfamiliar with Oraton, Oraton is Australia's, at least by my reckoning, oldest fashion brand, Australian fashion brand, founded in 1938. And we are a centralized team, very small centralized team, looking after a much bigger rest of the organization. And our tech landscape is dominated by one or two monoliths, namely our enterprise resource planning application and our POS system. And it's orbited by a number of little SASs, so these two little big planets and all these smaller ones orbiting around it. And our data is mostly moved around in a batch fashion. Why I think you might care about this conversation. So over here we have a reference diagram of a data stack. If you are in the pinkish purplish bucket of data engineering, you probably know all of the pains that I'm about to talk about. If you are in the blue bucket, typically the consumers of the magic that happens in the pink bucket, you probably have felt the impacts of this pain. And if you're on the green bucket, well, fantastic to have you here, because maybe you don't know about all of this, and we need more allies from that bucket. Before I get too far along with this, I want to give a shout out to Andrew Jones. Andrew Jones is, to my knowledge, the person that crystallized the term data contract within this current context. Published a book at the end of June. Was really helpful for me putting together my thoughts, so I just wanted to say thank you. And before I get too far, I just love this quote. It may be from a song that you recognize, narrated by Baz Luhrmann. It's actually from an article in the Chicago Tribune. And the gist of it is, take this advice from whence it comes from my context. And if I could tell you anything about the future, wear sunscreen. So what are data contracts? Over here I have two quotes. One of them is from Andrew Jones himself, the other is from Atlan. Now there's a lot of words on screen. Let's not try and read all of them at once, but what I want to draw your attention to is the mention of people. That you have a generator, consumer, parties. If you think about a contract in the real world, it involves people, and that's a core fundamental thing that we need to keep in our minds here. The other is about an agreement, so that's the blue text there, and then there's a mention there about having a structure, or an interface by which you access this. And then finally, the big kahuna at the end there, at least for my situation right now, there's a bit there about data quality, or having certainty about what you're going to get out of this. So let's take a scenario. We have Team A, Team B, Team C. And let's just say they're all working in the same organization. Data is flowing, everyone's happy. But what I haven't told you is that Team C have set up a non-consensual API. What do I mean by that? Well, Team C have found a read replica of one of the databases controlled by Team A and are pulling out data and using it for their own products downstream. But then, as always, change happens. Team A, their database goes through some changes. Team A had an understanding with Team B, so Team B knew this was coming, and they made the necessary steps to mitigate this change. And so their product is carrying on, still working. Whereas Team C, because they didn't have an agreement, didn't have an understanding, this change blindsided them, and so their products are now impacted and potentially not working. So if you've been working in that pink stack in the middle, as I was saying in the beginning, you know about this. You've experienced this, and maybe you've even caused this. So what makes up a data contract? Let's get to it. Well, a data contract could be as simple as this. This is a YAML document that's describing an event. It has some information about the contract itself, the version, who authored the contract. It also has service level objectives. So we're making a promise, an expectation about how complete this data set will be, how fresh it will be, and then below there's a collection of things that you might recognize as being schema. But what I want to really draw your attention to is that a data contract is not just schema. As I mentioned, it's people. If there is anything that I had to prioritize, and don't take the ordering as a prioritization, however, I will say this, if you don't recognize and understand the people, as in the people who are creating the data and the people who are looking to consume the data, and even the people who are responsible for maintaining the underlying infrastructure, if that is not captured and part of your data contract, you probably don't have a data contract. Other things that you might want to have in your data contract are schema. We love schema. Schema is great. Contract governance, so this could be things about, say, the version of the contract or the publishing state of the contract. Then there's semantics. Semantics is different from schema, and we'll talk about that in a second, but the TLDR is schema for machines, semantics for people, fair bit of overlap. Then there is a bit there about service level objectives, because again, if you are providing a contract, another thing that is inherent in the contract is an expectation of being able to get a benefit. Then there's the governance of the data set, so this might speak to how privileged is this information? Is it classified? Is it internal? Is it public? And then finally, maybe something about the mechanisms of transmission. So this might cover how the data was captured, whether it was from a human entering data into an interface, or was it a sensor, and then your expectations about how this data can and should be transmitted. Let's take a minute to take a slight detour about schema and semantics, because this thing is near and dear to my heart. As I said, schema exists in my mind for the benefit of systems. So you have a data type in your code. It's an integer. It's an integer because your system needs to make certain assumptions about it, so that if you try and do an arithmetic operation on that variable, it knows, treat this like a number. Whereas semantics is for humans and human expectation. Let's take an email address. From a schema perspective, what is an email address? It is a series of characters, one after the other. You might call it a string, or if you're speaking in database parlance, maybe it's a varchar, right? But for a person, we don't see it that way. We see it as this is a piece of information that has a very specific format that I can use to communicate to somebody. And I have expectations that I can use this information to have a conversation, right? And while we're on the topic of email addresses, there's a fantastic GitHub repo called Awesome Falsehoods. If you want to have a crisis of confidence about what you think you understand about email addresses, about names, about any sort of what you might think is a standard data type, go check out that repo and have your confidence utterly destroyed. But that repo is really speaking to sort of the semantics. There's, as I said, schema is about being able to store and retrieve information and do operations on the information by systems with confidence, whereas semantics is ensuring that we as people make the right interpretations and assumptions about the data that we're looking at. So what's the minimum amount of stuff that you need to be thinking about if you're looking to implement data contracts? Well, first of all, don't set out to implement data contracts, set out to solve problems. But let's say you're looking to solve problems with data contracts. Well, again, you're going to need someone generating the data and someone who wants to consume it. That's, again, people first and foremost. Then you're going to need to define the data contract. Now, this is from Andrew's book, and in my mind is fairly optimistic, as we'll see as we get towards the end of this talk where I bring it to my context. There is this optimistic hope that your data generators will define the contract, and then from that contract you can do things like provision an interface which represents a service that has its own database that the consumers can then interact with via that interface. I've put an extra little database diagram up there because the guidance that I'm seeing in the literature is you don't want to write a data contract against, say, your operational database. You want to have sort of a layer of abstraction, like an interface over the top. So maybe it's that you publish events of interest to a topic queue, or you provide a database, right, which is it gets its definition from the contract itself. Or maybe it's just a view that you offer up to your consumers, but you don't want to write it directly against your concrete implementation, because if you're needing to then change the internals, you then have to rewrite the contract, right? So you want that level of abstraction. So that is a key point not to be overlooked. So you've got this data contract. What can you do with it? A couple of things. From the data contract, you could generate some JSON that you can then feed into, say, CloudFormation or Terraform or whatever your infrastructure is tooling of choices, and then provision infrastructure. So you could take your data contract and provision a BigQuery table that has a schema as defined in the data contract, right? You could take your data contract and generate JSON schema. So if you're not familiar, JSON schema is an opinionated way for describing entities and their attributes. And from JSON schema, you could then generate APIs. So you're giving your consumers not only access to your data, but also the mechanism. They don't have to write any code. Here's a library. Have one for Python, have one for JavaScript, off you go. Another thing you can do with data contracts, and this is what brought me to this door, is being able to define data quality checks. All right. There's 3 places, broadly speaking, where you can implement quality checks. The first is at publishing time. So if you have influence over the system that is capturing the information, before that data is even written, persisted, you can do data quality checks to make sure that it's conforming, right? Or at the infrastructure itself. So say you pass it on to a message queue, you can then identify, does this event conform with my expectations? No, put it on a dead letter queue or manage it in some way. And then finally, there's after publishing. Now, if you're living in a batch world, this is probably going to be realistically where you're going to be doing a lot of your work. The one downside to doing it after publishing is that if you have errant data, it's out there. Right, so then you're going to have to think about, okay, what is our case management, incident management around data that's potentially leaked, and now there's gremlins all over the kitchen. So I'm going to bring it back to my context. As I said in the beginning, I have 1 or 2 big monoliths in my world, and one of them is the enterprise resource planning system. So for those of you who are not familiar with what an ERP represents, just think of it as perhaps all the microservices that you might have, but except in one box, in one interface, right? So people from various functions, from procurement, from finance, from design, they work in the ERP in various places, and that information gets written out to the ERP's database. And that eventually finds its way into my world in the data lake, pretty standard bronze, silver, gold situation going on there. And from that, we as the data team pick it up, clean it up, conform it to a model that we then present in a variety of ways, be it reporting, be it sort of analysis and discovery, and that's the value chain of data in my organization. But when I look at this again through the context of producers, what I see are producer boundaries. So there's a producer boundary all the way on the left where people are entering information into the ERP's UI. There's another producer boundary between the ERP database and where it gets picked up and ingested into the data lake. And finally, there's another producer boundary between where we as the data team have now generated these opinionated gold standard models and surfacing up to the rest of the organization. And the people on the right may also be some of the same people on the left. So again, in the beginning where we had that nice linear diagram of producers and consumers, they may actually be the same people in some situations. So at these producer boundaries, when I think about it, these are inputs to a data contract. So between the people working with and interacting with the ERP, that's where we can get an understanding of the semantics. One of the, depending on your point of view, perks of a lot of these ERP systems is that you can configure them in any way that you choose to. Often you're advised not to, but no one listens to that. They go ahead and configure it anyways. Or conversely, they don't configure it, and they just enforce rules by convention. So there is an understanding within the people operating the systems that, okay, this field over here don't populate it if these other things are true. So if it's a purchase order, say for apparel, don't fill in that field over there. But if it's a purchase order, say for materials, fill in that field over there. But that isn't enforced by the system, right? So that is where, again, the semantics of the data and the world that we're living in, that's where I can get that information from, having that conversation there. Similarly, between the ERP database, it materializing its information and its schema and its point of view, I can then start to pick up on the schema and perhaps the service level objectives that I can expect. Profiling the data, I might see that it looks like there's a purchase order raised every day, so maybe that's a test that I could write. Expect that we will see at least one record every day appearing in the table that represents purchase orders. And then finally, I will take those two things in my context and then generate the checks and tests which I'm applying at that last boundary over there. The reality that I have defined since starting this journey, it's been about a month and a half now, is the people at the very end also have their interpretation of the semantics. So again, that initial diagram that had this ideal linear, left to right flow, in reality, it may be a little different. So consider the people at the beginning and at the end, because they may have slightly different but still significant interpretations of what the data means. So how are we going to make this all happen? Well, we're going to use awesome people that understand modeling, that understand abstractions, and understand constraints. And I think I'm looking at them. We could even do it in code, and you should definitely version control it. But you might be thinking, hold up a minute. A couple of slides ago, you showed me a YAML document and said, this is a data contract. Why are we talking about code now? A couple of reasons. Predominantly, documents, be it a Word docket, Excel document, even to a lesser extent, a structured document like JSON or YAML, they suffer in varying degrees from what I describe as the entanglement of meaning and representation. So the simplest example I can give of this is, say you've got a Word document, a rich document that people can apply formatting to. You can start typing a sentence, a statement of fact. Later, you can come back to that document and apply formatting that strikes through that sentence. When reading that document, you as a person interpret that, oh, that sentence is no longer valid, it no longer applies. However, if you parse that document, you may not pick up on that. So again, it's the entanglement of meaning and representation. When we write code, we say exactly what we mean because we have to. Another reason why you may want to consider doing this as code rather than a whole bunch of documents is finding references. So when you have your code and you want to find where a particular variable has been used, it's pretty straightforward these days. We've got wonderful tools. Just right-click, find references. There's all the places. But if you're doing this with plain text, you've got to do text matches. And that just opens up a whole can of worms that you now have to figure through. Finally, there's some other good stuff, like we can test code, and ultimately, if you need to represent that knowledge as, say, a JSON or YAML document, you can do that from code, right? And again, speaking about refactoring text, you might think, Ryan, but I am a wizard at regular expressions. I got this. I believe the same until I have to do it, and then I find myself doing a whole bunch of Googling or playing around with a regex tester, right? Not knocking regular expressions, they're fantastic. I just think that my little brain can't keep track of them for long enough to remember what I need to do the next time I need them. So coming back to my context, what was considered? As I said, the first thing is I didn't set out to implement data contracts. I had a realization that there was this misalignment around the expectations and the understanding of the information that was being entered in at the beginning of the journey, the slice that I showed you there, and at the end. There was a lack of knowledge, there was gaps in our understanding. So first identify a problem that you believe can be addressed by establishing and documenting your consensus. Next step is, of that big problem, find a small scope. Let's do something small first rather than trying to boil the ocean, and make sure you've got allies, people that are willing to work with you on this. Secondly, identify what your constraints are. Every organization is different. Every situation is different. You may have more engineers available to you. You may have few. You may have great engagement with your business. You may not. The next thing I would say is keep it people and process-centric, right? If you are looking to address a part of your world that doesn't involve people, I would say that a data contract isn't necessarily the way to go about it. If you're looking at interchange between a system A, system B, no people involved, you could probably get done what you need to get done with an API. Just keep it simple. Next, because I had this hairballed idea of doing this all as code, I had to think, well, I'm going to need some sort of way of modeling all of this. Right? So I described this as my meta schema. And then finally, and this is where I'm going to contradict myself in a couple of slides, I was looking for ways to maximize opportunities for people to contribute. Let's talk about those guiding principles. The primary objective for me was establishing consensus. And the first outcome that I was looking for was data tests. As I mentioned, you can use data contracts to create infrastructure, create other tooling, but for me it was really about I want to have confidence and be able to confidently say to other people that you can expect the data to have these characteristics and these guarantees. Then around that meta model, when I was thinking about it, what I wanted to capture was the meaning and understanding of our data from the UI all the way down to the database. Right? It was really about having that end-to-end lineage going on. And understanding and recognizing that there is schema and there's semantics, they're similar but not the same. And truthfully, I'm still figuring it out. I was sitting in last night, one, not being able to fall asleep because I was worried about catching my flight, and then two, thinking, I don't like the way I've named certain things, and we'll get to that in a second. Here we go. Here it is. So here's a representation of my meta schema for my data contracts as code. So the black stickies are what I describe as contract governance, so the version number, the publishing status, who are the people involved, and any service level objectives that I'm trying to achieve with this data contract. And then within the data contract, I've gone for keeping it, again, centered around events. So an event occurs, say, supply created. And off of that event, you may have one or more entities. I don't like that word. I'm still thinking of a better word, but bear with me. And an entity has one or more properties. And a property, and this is where I was keeping the representation of the semantic and the schema separate. A property is a composite. It has an attribute, which is to speak of the semantics. And then it has a source, which speaks of the schema. So I'm living in a relational world, so my source is comprised of a table or column in a database. But if you're working, say, with a document database, that might be, say, a key, a record, a collection. Or if it's hiding away in an Excel document, it could be a workbook, a sheet, a cell, right? Allowing myself dynamism for the future potentially. The other thing I want to call out there is explicitly modeling the semantic type. Now, the reason that I believe that this is worthwhile and necessary to do is the implementation of a semantic type, let's say email address, may differ wildly from one system to the other. So if I have knowledge that system A, we have attributes of the semantic type of email, and I need to exchange to system B, I can then write some code that does that translation for me because I have that hook that they're both semantically an email address. Poor example, but bear with me. So how are we going about doing this? I'll take a moment and give you a chance to look at this, because you're probably seeing that Excel icon going, Ryan, what the hell? You're just saying you're doing this as code, but there's an Excel spreadsheet over there. Are you crazy? Probably. No. Again, coming back to my constraints and principles, you may recall I said I was looking for opportunities for other people to contribute. So going on this journey, I have a business analyst that has been lent to the team. They're fantastic. Really couldn't sing high enough praises about them. And when I was thinking about, yeah, let's do this as code, I thought, they can learn Python. They're smart, they'll get it. But again, the constraint was we needed to move quickly. We don't have a lot of time to do what we need to get done, or rather, we need to prove value very quickly. And thus, I came to the realization of, well, if they're going to be doing a lot of the legwork, talking to people, and having these conversations about what does this mean and where does it go, a spreadsheet's acceptable, right? So we have the spreadsheet where they're capturing all the knowledge about the events and what's involved in them. That spreadsheet gets committed to a Git repository, where then I've got a CI/CD pipeline set up where it reads in the spreadsheet, generates my code models. Those models are tested, and now we have new contracts expressed as code models. And then soon in the near future, from those code models, I can then generate all sorts of things. Right now, I'm just generating very simple SQL-based tests, So if an attribute is marked as it must always be present or it must be unique, I can generate tests that automatically test that for me. And you could do it using Great Expectations or Soda or any other of the testing libraries right now. I've just implemented it as basic SQL because I have yet to make that decision about where to go next in terms of testing. So who's going to do the work? Coming back to this optimistic diagram. So hopefully these people, the data generators, but in my experience, being part of a centralized team, because I'm in the category of data consumers in reality, but I'm having to drive that process. So again, your mileage may vary. So if you go out and read the literature and you see this sort of idealized state, and you think, well, hold on, that's not going to really be how it plays out for me, don't worry. I'm having this too. So we're at a Python conference. Let's talk briefly about what we're using to do all this stuff. So some helpful Python libraries. Pandas for reading in the spreadsheet. What you may find is that if you do go this route and hand a spreadsheet to somebody and say, please fill in the spreadsheet, you give them a very opinionated structure, you may get back what I describe as a sparsely populated Excel spreadsheet. So the first column of my spreadsheet is the event. And I had the expectation that they would write the event name on every row. Not the case. They write it on the first row, and then I have 5 blank rows, and then the next event name appears. So long story short, pandas read in the spreadsheet and then forward fill. And also pandas is great just for any other manipulations you need to do. Pydantic for defining my models. What I love about Python, amongst other things, is Python is what I would describe as a gradually typed language. Working in Python, if you're not sure what a variable is going to be, you don't need to tell it, hey, this is going to be an int. And if it isn't, your application immediately goes kaboom, right? But however, with the introduction of type hints and libraries like Pydantic, as you get more certainty about what you're going to be bringing in, you can model it, use it, and off you go. I'm using Rope because the models that are initially generated are quite verbose. And Rope is a fantastic library for manipulating your Python code and effectively changing it. So you use Python code to manipulate Python code. And then PyTest, MyPy, and Black just for hygiene and having confidence. So talking about the generated model, here's an example of one. Right, as you can see, it is very verbose. There's a lot of inline variable declaration going on here. And as you may recall, one of the reasons why I wanted to do this as code is so that I could get the benefit of being able to do things like refactoring or finding references. What I would prefer is something that looks more like that. Because down below there, I've highlighted a variable attribute company. And because that attribute conceptually appears on multiple entities in my code, because I've refactored it and extracted it as a variable, I can now, in my IDE, right-click, say, find references, and on the very far right-hand side, you can see all the other places it's been referred to. I've got a little Colab notebook here, which demonstrates the use of Rope to extract and refactor code, extract variables and refactor your code. Don't have the time to go through it all right now. I'm sharing this because Rope, while it is a fantastic library, its documentation as to how to apply it in terms of recipes, I haven't really found a whole lot to help me out. So have a look, have a play. But to explain this code very briefly, I'm first finding in my abstract syntax tree the nodes, because that's how your code is represented, that I want to manipulate, identifying their character position in the code, and then I am I'm defining a new variable name for it. And then for each of these variables that I found, I'm using Rope to extract the variable, telling Rope to identify the changes it needs to make, and then it makes the changes. And thus, I go from this very verbose code to this nicely condensed code. So some further options, as I said, the code that is generated is quite verbose, and there's some more things that I would like to implement to make it a little bit easier to work with. I won't go into all of this, but if you have any thoughts about how I might achieve this, I'd love to hear from you. So, some key takeaways. You may be a data producer and you may not know it, okay? So make it worthwhile for people to register with you as a data consumer. And a data contract is a way to go about doing that. And then finally, code is easier to refactor, find references, and generally maintain than the alternatives. And with that, thank you for your time, and I look forward to catching up with you all.
Thank you, Ryan. That was really good. Yeah, it turns out when you add people into the mix, it gets a little bit squishier and messier, and especially many of them. Some really good sort of actionable, or solid strategies for digging into it. We probably have time for maybe a quick 1 or 2 questions. Do we have any? Yes. I'm gonna hand this. Can I give that to you? There you go.
Hi. I was wondering, with your contracts as code, is it your intention that the code will test the inputs to a system in real time, or just in the test environment, or where are you going to deploy it?
Potentially. So, as I said, my world is very batch-driven right now. We do have aspirations for moving some of our flows to be more event-driven. So things that are critical, say, the activation of a gift card. We want customers to be able to buy a gift card and use it immediately rather than waiting for the current, uncomfortably long period of time that it takes to activate. So in that scenario, I do see a very real extension of what I have to be able to, receive events, test them, validate them, and, pass them along should they fit. Yeah.
Cool. Alrighty, thank you. We might call it there. It's time for our break. So firstly, before we move on to the next things, a little gift for you, Ryan. Thank you very much. And one more round of applause for Ryan.